Hello, this is the video for lesson number 8, solving for unknown angles with transversals. Now, before we get started with the pictures we see down here, just a couple quick little review facts we want to bring up here. First, when we're looking at the angles we're going to see today, it only works if we have parallel lines. So our little symbol for parallel lines are these two arrows that I drew on these two blue lines here. And a transversal is just any diagonal that cuts across them. And if you look, and especially at the pictures we have down on the screen, that creates 8 different angles. And these angles all have names depending on which pair of angles we're looking at. First type we're going to look at is interior angles. So if I just highlight our two parallel lines here in yellow, the interior angles are all 4 angles here, 3, 4, 5, and 6, that are just inside the parallel lines. For the same reason, on the next example where it says exterior angles, these are just the angles on the outside of the two parallel lines. So that would be 1, 2, and 7, and 8. Now, specifically, when we look at pairs of these interior or exterior angles, there are certain properties that are going to be true about them. The first one is alternate interior angles. And what I'm going to draw on the board here is going to look like a little letter Z. In that picture, if we know that these two lines are parallel, because if they are not, we do not have any of these angles showing up. But if we do know these lines are parallel, these two angles here, angle 3 and angle 6, are going to be congruent to each other, which means they have the same measurement. The same thing is true about the other pair of alternate interior angles, angle 4 and angle 5. They are also congruent to each other because of alternate interior angles always being congruent. Same thing happens here for alternate exterior angles. If I look at my two parallel lines here, and I pick one angle on the outside, if I pick the angle in the opposite of the picture, which would be angle 8 here, opposite side, on the opposite side of this transversal here, those two would be our pair of alternate exterior angles, which are also congruent. And for the same reason, angle 2 and angle 7 is another pair of alternate exterior angles. Down at the bottom here, we have something called corresponding angles. And to me, the word corresponding kind of sounds like the word corner. These are angles in the same corner of the parallel lines with the transversal. So here, angle 1 and angle 5 would be considered corresponding. Same with 2 and 6 there. We would also have angle 3 and 7 being corresponding, and also 4 and 8. Basically, if you look at it and look at the colors we have there, any angles in the same position on the parallel line with the transversal, either top left for green, top right for purple, are called corresponding angles. They are also congruent as well. And the last type we're going to talk about today, same side interior. It's kind of the opposite of alternate interior angles. If I look at my two parallels with the transversal, any two angles that are interior and on the same side, like angle 3 and angle 5 here, happen to add up to be 180. They're the only angles that we're going to talk about on this page that are not equal, but they are supplementary, as it says on this last line down here. Same side interior angles are complementary. The other two above, corresponding, are congruent, and alternate interior are congruent also. So we're going to look at a problem now that gives us a pair of parallel lines shown by our definition right there. If they were not parallel, we could not use a lot of the angles we're going to see here. So we have two parallel lines and a transversal kind of cutting across. So the one they tell us is angle 1 is 150 degrees. Well, automatically, if we know that, angle 1 and angle 2 here are a linear pair or supplementary. So if angle 1 is 150, angle 2 would have to be 30 degrees. Likewise, if I know angle 1 is 150, angle 4 is vertical to that, so it would have to be 150 degrees also. And for the same reason, if angle 2 is 30, angle 4 would have to be 30 because it's vertical with angle 2. And again, here are the reasons for those first 4 angles up top there. So I'm just going to fill in angle 3, also 30, angle 4, 150. Once we have those top 4, the bottom 4 angles are all exactly the same. If we use the corresponding angles property, every angle in the same position, top left, is going to match the same angle down here in the top left. Same for top right is 30, so is angle 6. Bottom left is 30, bottom right is 150. And we see the reasons here, they're all corresponding angles. So it's another 150, 30, 30, and 150. And that's always going to be the case when we just have a simple picture with 2 parallel lines and a transversal. The same numbers are going to show up in all 4 spots here. In example 2, we have to do a little bit more work here with our parallel lines. So again, I'm going to highlight that they're parallel and just put those little arrows there. In picture number 1, in example 2, we have these 2 angles here and here. And these 2 types of angles are corresponding angles. And because of that, corresponding angles are always congruent in parallel lines. So I can set these 2 angles equal to each other. And then if we want to solve it for x, we can add 13 to each side and get x is 96 degrees here. Likewise, in the second picture in example 2 here, we have 2 more parallel lines with a transversal. The 2 angles we have here are alternate interior. And again, I can tell that by that Z shape that I can draw. So let me just write out alternate interior angles. And again, those 2 types of angles are congruent also. So we have 5x squared minus 25 equals 4x squared plus 75. We're going to combine like terms again, so I'm going to bring all the x squareds to one side. So we get x squared minus 25 is 75. These cancel. We're going to add 25 to both sides. I'm going to put the rest of my math up top here. So we have x squared equals 100. And if we have x squared and we want to get just x, the opposite of squaring something is square rooting it. So we get x equals 10 for that second example there. Down at the bottom of the page, we have 2 more types of angles. Again, identifying what types of angles we have is the most important step to know whether or not to set these 2 angles as equal or add them up to 180. In this picture, we have same side interior angles. Again, the reason for that, they're in between the 2 parallel lines, but they're on the same side of that purple transversal. So these 2 types of angles are supplementary. They add up to 180. So I'm going to add up x plus 40 plus 3x plus 60. Set it equal to 180. And then I'm going to combine like terms. 4x plus 100 is 180. Subtract 100 on both sides. And we get 4x is 80. And then we can divide by 4. And get our answer for this one, x equals 20. The last example on this page, the 2 angles they give us inside the parallel lines here don't actually have a definition. If I look at them in particular, this 4x plus 5 is on the outside. The 2x minus 11 is on the inside. They're not corresponding because they're not in the same corner, top left with top left. So what we can do first is notice that this 4x plus 5 has a vertical angle equal to it right here. And now these 2 angles, 4x plus 5 and 2x minus 11, are same side interior, just like the example on the left here. So these two angles have to add up to be 180 again. So I'm going to add these two angles up to 180. I'm going to combine like terms. 6x minus 6 equals 180. Add 6 to both sides. 186. And for our last step, we divide both sides by 6, and we get x equals 31 degrees there. Okay. The last thing we're going to look at here is our last page. And this is kind of a mix of all the examples we've seen so far. So again, in exercise number 1, we have two parallel lines here. So I'm going to highlight those two along with the diagonal. And we see these alternate interior angles again. So if angle down at the bottom here is 35 degrees, this, because of alternate interior angles, is also 35 because the lines are parallel. If this angle is 35 degrees, these two angles are angles on a line or supplementary angles. So if we do 180 minus 35, we're going to get angle 1 is 145 degrees. In picture number 2 here, it can be a little confusing because the picture looks like it's tilted a little bit. But again, if I highlight our two parallel lines here with a transversal that cuts across both of them, or one of the transversals. So in this diagram, angle 54 degrees and angle number 2 are another pair of alternate interior angles. So angle 2 is going to be 54 degrees for that reason. On the bottom side of the picture here, if I look at, I'm going to highlight this in a different color, in purple here, 3 and this angle with a little purple dot in it are also alternate interior angles. So I can put that number 3 there because they're the same. So now if I want to know how big angle number 3 is, I notice I have another pair of supplementary angles right there. So I can do 180 minus 112. And if I subtract those two things, we get 68 degrees for angle number 3 there. If I move down to the bottom two examples here, again, even though the picture is a little bit more complicated looking for number 3, if I just go back to highlight those alternate interior angles again with those parallel lines, if I have a 46-degree angle in the bottom, angle number 6 is also 46 degrees because of alternate interior angles. For the same reason here in purple, I'm highlighting my two parallel lines to the transversal. My 92-degree angle is alternate interior with number 4 there. So that's the measurement of angle number 4. And last, all 3 of these angles are angles on a line. So if I want to find number 5, 180 minus 92 minus 46. And if I subtract those two angles from 180, we get 42 degrees for the last angle, angle number 5. In our last example here, very similar idea. I'm going to highlight our two parallel lines, one of the two pairs of parallel lines. And one of the types of angles I'm going to point out here is corresponding angles. These two angles, if I look at them compared to the parallel lines and the transversal there, are in the same position between the red and the yellow angles in the bottom left. So angle number 8 also has to be 94 degrees. And if I want to find number 7, I can do the same thing with that 68-degree angle. Here's the second pair of parallel lines, the purple ones. So if that 68-degree angle is between the purple and the red, that angle's got to be 68 degrees also. So lastly, if I add up all 3 of these angles that are on a straight line, I can subtract them from 180 to get the leftover measurement of angle number 7. So 180 minus 94 minus 68 will give us 18 degrees for angle number 7. And that is the end of that lesson.